Welcome back. This is last lecture of physics chapter units and measurement. In this lecture our topic will be dimensional analysis. So let's begin. So in the first lecture we have studied about base quantities and derived quantities. The 7 base quantities act as the 7 dimensions of the physical world. All the derived quantities can be expressed in the terms of some combination of the 7 base quantities. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. So let's understand this with the help of an example. Let's take the example of velocity. So we know that velocity is equal to distance upon time, or velocity equals to length upon time. So in this equation, the power of length is 1 and the power of time is minus 1. So velocity can be written as length to the power 1 and time to the power minus 1. Thus, the dimension of velocity in length is 1, the dimension of velocity in time is minus 1, and the dimension of velocity in the other base quantities is 0. So if we put mass in this equation, then the power of mass will be 0, because anything raised to the power 0 is 1. So it will not affect the equation. Thus all the other 5 base quantities which are not present in this equation can said to have the power of 0. So velocity can be represented as Lt minus 1. So we use symbols for representing the equations. Now there is an important note here. So we have to put square brackets around the quantity to represent that we are dealing with the dimensions of that quantity. So we will put square brackets around velocity as well as the other side. So it will become that square brackets around velocity equals to Lt minus 1, again in square brackets. Now let's write few other quantities in the terms of their dimensions. So the first question is to write force in the terms of its dimensions. Now we know that force is equal to mass into acceleration. So therefore force is equal to mass, its symbol is m raised to the power 1, into acceleration. Now acceleration is nothing but velocity upon time. So therefore we have already derived the dimensions of velocity, and that is Lt minus 1, and for time it will be t. So acceleration can be written as Lt minus 2, because when this t will go up, then the power will become minus 2, and the mass will be m raised to the power 1. So the final dimensions of force would be m1 Lt minus 2. So it can be written as m Lt minus 2, because we do not have to mention m whenever the exponent is just 1. So therefore force is equal to mLt minus 2, and we will put square brackets around it. Now the second question is to find the dimensions of kinetic energy. So we know the formula of kinetic energy is half into mass into velocity square. So half mv square. Now in this, half will not have any dimension, because half is a number and numbers don't have any dimension. So half is dimensionless. Now let's come to mass. So mass will have a dimension m1, and velocity will have a dimension Lt minus 1. Now because there is velocity square, so that's why this will also be squared. So basically it will become L square T minus 2. So the final dimensions of kinetic energy will become m1 into L2 T minus 2. So basically kinetic energy will be equal to m L2 T minus 2. Here we have another question. This time we have to find the dimensions of plane angle. So the formula of angle is arc length upon radius. So arc length is also a length with the symbol L, and radius is also a length. So both of them will get cut. So therefore, the dimensions of angle will become L raised to the power 0. So therefore, we can say that angle does not have any dimensions. Angle is dimensionless. Now, after studying about dimensional analysis, let's study few applications of dimensional analysis. So how is dimensional analysis used? First, to check the dimensional correctness of an equation using the principle of homogeneity. So using this dimensional analysis, we can check whether an equation is correct or not. For this, a very important principle called the principle of homogeneity is used. According to this, only the same physical quantities can be added or subtracted. So the physical quantities having the same dimensions, only they can be added or subtracted. The dimensions of all the terms as well as the result must be the same. So if in an equation we have two terms and they are getting added to get the sum. So in this equation, both the terms as well as the sum should have the same dimension. So for example, if they are in length, so all the three must be in length. So here we have a question based on principle of homogeneity. This question says that we are given this equation S is equal to ut plus half at square, which is also the second equation of motion, and we have to check whether it is correct or not. So we have to verify whether it is dimensionally correct or not. So for this, we will derive the dimensions of this equation, and then we will check that if the dimensions of the result of the sum are equal to the dimensions of the terms, then it will be dimensionally correct. So we know that S is nothing but distance, and the dimension of distance is L raised to the power 1. That is length raised to the power 1. Now in ut, u is velocity, so its dimensions will be Lt minus 1 and multiplied by t, that is time. That's t raised to the power 1. And half at square, half will be dimensionless. A is nothing but acceleration, that is Lt minus 2 multiplied by time square, t2. So now Lt minus 1 into t1, so t minus 1 and t1 will be nothing but t0, so this will become L. Now again t minus 2 and t2 will again cancel to form t0, so again we will get L. So basically we have got the equation's dimensions, that L is equal to L plus L. So all the terms as well as the sum is in the dimension of L raised to the power 1. That's why we can say that this equation is dimensionally correct. Now there is another use of dimensional analysis. This is to derive the relationship between physical quantities. Let's solve a question to understand this better. So here we have a question, and in this question we will derive the relationship between the physical quantities. The question says that the time period of a simple pendulum depends upon its length and acceleration due to gravity. Find the expression for time period. So from this question we can infer that time period is directly proportional to length. Let's say it is raised to the power a, and acceleration due to gravity, let's say it is raised to the power b. So t is directly proportional to L raised to the power a into g raised to the power b. So basically, to remove this sign of proportionality, we can put a constant. So time period will be equal to k L raised to the power a into g raised to the power b. Now from this, if it now we have to make the dimensions of this equation. So we will get that because the dimensions of the time period will be t, and dimension of length will be L, and L raised to the power A. And for G, the dimensions will, because G is acceleration, so the dimensions will be Lt minus 2 and it is raised to the power B. So therefore, it will become, if we multiply it inside, so it will become L raised to the power B into T raised to the power minus 2B. Now we will multiply the powers of L, so it will become L A plus B into T minus 2B, and this is equal to T raised to the power 1. Now to add L also to the right hand side of the equation, we can write L raised to the power 0, because anything raised to the power 0 is 1. So adding L raised to the power 0 will have no effect on the equation. Now we just have to compare the right and left hand side of the equation. So here on the right hand side we have L raised to the power 0. On the left hand side we have L raised to the power A plus B. That's why A plus B will be equal to 0. And from second equation we can get that T raised to the power 1 will be equal to T raised to the power minus 2B. So comparing the exponents, we will get that 1 is equal to minus 2B. So from here, from both these equations, we just have to solve them to get the values of A and B. So from the second equation, we can get that B is equal to minus 1 upon 2. When we take this minus 2 to the other side. And putting the value of B into this first equation, we will get that A is equal to 1 upon 2. So this was the question which had been asked, that we had to calculate the exponents of the equation. So from this, the final equation will become that T is equal to K length to the power half and G to the power minus 1 upon 2. Now anything raised to the power half is root, and anything raised to the power minus 1 will become will go into the denominator. That's why T is equal to K L upon G in the root. This will be the final equation, that T is equal to K root of L upon G. So with this, we come to the end of this chapter. If you like the video, then do subscribe to the channel, and if you have any doubt, then ask in the comment box. The link of the notes will be available in the description box,